So now we're going to talk about the API gateway pattern, which is something we haven't discussed at all at this point and is very important to understand the way that Spring is used in production systems. So we're going to see that the concept behind this is actually a very simple concept. You have this thing called an API gateway. Why is it called the API gateway? Because it implements a bunch of APIs or API calls, and it basically intercepts those calls from clients. Maybe intercepts the wrong word. It's the designated target for the calls. And then the gateway is responsible for routing the requests to the appropriate microservices running in the backend. So this is basically what it looks like. It's got a single entry point for all the backend APIs and their microservice implementation. So this is kind of the front-end server component, and then you've got a bunch of back-end microservices that actually really do the work. Why do we do this? Several reasons. First, it provides a unified experience for users. Of course, the user doesn't really know or care. The end user doesn't care, but the person writing the code, talking to this system, that's a user also. It's a client. And that makes it more consistent. You only have to have one entry point, say one URL with one host name or one port number and so on. And that's what's exposed to clients that need to access this. The clients send their requests to this API, and we'll see when we look into this in more detail. Encoded in the URLs, or the URI portion of the URLs, will be information that the API gateway uses in order to route the requests to the appropriate microservice. So you can see here that the gateway has these routing and gateway handlers, which have all kinds of interesting features for identifying parts of the request and filtering things and stripping stuff off and so on. And then they go ahead and forward it on to the microservice in the back end. So that's what the gateway does. We don't have to write this code. This is really cool. This is done declaratively. We just have to figure out how to specify what we want, and then the Spring Cloud Gateway does all the nitty-gritty to make it work under the hood. And then the back-end microservices, which the gateway routes to, they actually do the work, and I don't really show it here, but they return the response back to the client. The microservices, this is another kind of cool thing. The microservices that are actually doing the work could be either internal or external to the service. So if they're internal, then they would be implemented by the people doing the back end. If they're external, they could be other microservices that could be provided from other sources. For example, there might be a microservice that would do things like provide stock quotes or weather forecasting or whatnot. And so you can imagine a whole economy of microservices out there from third-party providers for either a fee or some other form of chargeback, or just because out of the goodness of their heart, they provide you with a way to get access to this information. So you can build applications by essentially stitching together a bunch of microservices by different providers, and the gateway then manages all those different relationships. So let's talk about the pros and cons of this particular approach. So the good thing about an API gateway is it simplifies the client because they have one-stop shopping. They only have to talk to one thing. So there's only a single service API that's needed to access all the system capabilities. So that means there's less complexity on the client side. Keep in mind the clients are typically things like web browsers or mobile apps and so on. It could be desktops too, I suppose. It also potentially improves microservice security. And the reason for this is that you can limit the access of external client calls via one public port number. So you might expose port 8080. That's a nice common port to use. And that way, only that port is exposed through your firewall. And all the other ports are locked down, so clients, malicious clients, bad actors can't come along and search and scan your system to find points of vulnerability. And all the backend service ports, whatever they might be, those are also hidden from clients that are not happy, friendly clients. Another nice thing is the clients don't need to know anything about the internal system architecture. So they don't know, they can't know, they don't care, they shouldn't care, they can't care where the microservices are actually running. And those could be put anywhere. They could be running on one computer, they could be running on multiple computers, they could be in some kind of distributed web, whatever you want to do. So as a result, the clients have less to worry about, and the implementers also have less to worry about because this information is not leaking out to the clients, which is just yet another source of attack vector for bad actors. There's also some other nice properties here because you can have certain cross-cutting concerns. Authentication, we mentioned that before. Monitoring, things for like logging that you might use for accounting purposes. Load balancing, resilience, all those kinds of things can be localized to the API gateway and handled here. So the back end doesn't have to worry about that, and you can have this sort of single point of management of the system. But there are some downsides, as always, which is fine. So one of the problems is there's more moving parts, and there's an associated learning curve. Now, it's not a vast learning curve, as we will see as we walk through it, but it is something new. And if you haven't worked with these kinds of systems before, it's yet another markup language. Even though YAML ain't a markup language, it's yet another markup language to learn. So there's some additional effort required. And another thing you'll see when we start looking at the YAML files, they're very, very persnickety. They're very, very sensitive to indentation and formatting and things like that. If you put one stray character in the wrong place, you're going to get bizarre errors at runtime. You'll be like, what the heck is going on? We'll talk a bit more about that in the next part of the lesson. So they're fairly simple to understand, but it takes a while to debug stuff if you don't do it right. And of course, because we've now got lots of these moving pieces, there's additional deployment and orchestration mechanisms required. And you will see this when you start running assignment 2, because you're going to have to actually hand launch the different microservices in order to test your program. Whereas before, you could just run a Spring Boot test, and it would automatically launch the application in the context of the test. And now for doing a more thorough and fulsome integration test, you have to manage the starting of those services. Now, again, in real life, we would have some kind of Kubernetes or Docker orchestration to do this for us, but that was extra work we didn't want to get into here, and it also would make things more complicated in terms of what platform you could use for running the servers. And another potential issue, although in practice this isn't really the long pole in the tent typically, is there are some extra levels of indirection, because clients aren't talking directly to the microservices, they're talking to them indirectly through the API gateway, and even though the amount of code you write is minimal, there's still a couple extra hops that need to be taken into account here. So you just have to be aware of that. And of course, the alternative way of doing things, the way we've been doing up to this point, is by using a direct client to microservice model, where the client applications knew about the microservices and they talk to them directly. So in this model that we're showing here, each microservice has a public endpoint with different TCP port numbers and host addresses and so on. But the problem with that approach is it doesn't really scale. It's only useful for the kinds of simple test cases I've been showing you up to this point. And as soon as you get production-grade systems with lots of microservices, you don't want the clients talking to them directly for all the reasons we just talked about. By the way, that would be a great quiz question, is to talk about the pros and cons of using API gateways. So that's the end of the discussion of the API gateway pattern. And keep in mind that this is something that's not limited just to Spring. Other ways of being able to do modern web services architectures can also use a similar approach, similar pattern. Next, we're going to talk about how Spring implements this.